Hello. Welcome to another day of the Internet Measurement Village. Joining us today is Vesna and Emile from RIPE, who will be telling you about the work that they're doing at RIPE with respect to Internet measurement. Thank you for joining us.
Hi, thank you for inviting us.
Yeah. So, floor is ours.
Off to you.
Hi.
Yeah.
Thank you. So our goal today is to inform you and to inspire you to use the tools that we are maintaining and together with the community.
Yeah, and the first part is going to be a little bit about information about what we do and what we have, and the other part is hopefully you'll get inspired to do something with it. So yes.
So I'll give you a very brief introduction into the differences between RIPE and RIPE NCC. So it's quite confusing. People often say RIPE when they mean RIPE NCC, but there is a very clear difference between them, and that is that the RIPE is a community, and it stands for Réseau IP Européen, pardon my French. It's so the European IP networks, and the RIPE NCC is the network coordination center for the RIPE community. So the RIPE is not a legal entity, and the RIPE NCC is the actual organization with the office, which is currently empty because we are all working from home. So the RIPE community started a long time ago when several researchers from the early internet age wanted to coordinate their technical connections between their organizations and their networks. And so they started meeting in person and having mailing lists. So they're all volunteers, and this is how it remained until today. So the whole RIPE community is focused on the coordination and collaboration. How do we do that? Well, it's completely open. Anybody can take part, and the topics are divided into multiple working groups. So for the Internet Measurement Village, the most interesting one is so-called MAT working group, which is measurements, analysis, and tools. And there are other ones that could be interesting for you, like the open source or cooperation, which is more about internet governance and other governing bodies that are not so much involved into the really technical details like DNS, routing, IPv6, and so on. You can subscribe to the mailing lists, and you can contribute. And if you are very new to all of these topics, then the RIPE meetings are actually quite a good opportunity for learning more. The RIPE NCC, on the other hand, is the actual organization. It is situated in Amsterdam, in Holland. It's a membership organization, so we are funded by membership fees, and we are not for profit. Our main task is to distribute internet resources, IPv4 addresses, IPv6, and AS numbers. The rules for distributing those resources are decided by the RIPE community, so it gets really complicated. So we do have members, but then we also have community, and no wonder that people actually confuse the two often. So the RIPE NCC is in itself also supporting a lot of technical coordination, so we help the RIPE community, for example, to organize those meetings. Another big important task is to maintain the RIPE database where all those internet resources are registered. And so it's a so-called WHOIS database, but now we just prefer to call it RIPE database. We are one of the 5 regional internet registries. You can see the map here with the service regions of other regional internet registries. And we also then distribute addresses in the hierarchical way. So we give them to the local registries. And for example, in Asian Pacific region, they have another layer, which is national internet registries, which don't exist in Europe. And so every region actually decides how do they develop these policies which are most suitable for their way of working and their economies and their culture and so on. So we would like you to get involved, and we are very much aware of the aging of the RIPE community. So we have introduced a lot of programs to bring young people to our meetings, and one of them is the academic support program, which is called RACI, the RIPE Fellowship, and we also have a diversity task force. Apart from these large meetings that used to be in person, but this year they are virtual, just like everything else, we also used to organize regional meetings that are much smaller, but then we go to different parts of our service region, a lot of training courses, and of course hackathons that we will mention later. Also, something important is that this week our Community Projects Fund is going to be open for this year. So we give money to the open source projects which benefit the community. So if you're interested in that, you can find the links on our website. And finally, the RIPE Labs is our blog, and we would welcome your contribution to it.
That's actually a cue. If you want to ask questions, then we have a little tune for that. It's very, very developed, this. So I'm going to switch topics a little bit, if there's no questions, of course. But what about data? So this is a presentation about measurements, and so I want to focus a little bit more about this on the data side of things. At the RIPE NCC, we collect a lot of interesting data, and a common theme there is that this is for the community by the community. What I mean by that is that this is network operators typically, and everybody who is involved in the internet, putting stuff in place to be able to measure the internet and give it back to the internet. And it's really similar in spirit, I think, as the OONI project, sorry for my pronunciation. And so I'm going to focus on two data collections. Actually, we do more, but these are the sort of the places where we collect raw, unprocessed data. It's a RIPE Atlas, where we collect latencies and path. So how fast do packets travel the internet, and what path do they take? So how is the network experienced? And we have RIPE RIS, that is the control plane, and that basically answers how does this routing actually work, and where should these packets be routed? So that's the two that I'm going to focus on as our raw data collection platforms. And of course, you can ask yourself the question, why do we do this type of thing in the first place? And for us, it's simple. It's in our mission. And this is literally if you go to our About Us page, as a neutral source of information and knowledge, we actively contribute to a stable and innovative internet. And of course, to say it a little shorter, to measure is to improve. And in my home language, my native language, Dutch, mate is weten. It's a very common thing. The first part there is RIPE Atlas, and that's basically seeing your network from the outside. So RIPE Atlas is a global, open, distributed internet platform, measurement platform that's operated by us, by the RIPE NCC. We have these little devices, RIPE Atlas probes, and well, it started with the little devices, but now we also have one new like server type. We do VMs, we do software probes, but it's over 10,000 devices right now, and they're actually measuring the internet in real time. So it's pings and trace routes, and well, in the second part, you'll see a lot of examples what you can actually do with this. And important, it's open data. It's available to operators, network, research community. Yeah, I said it's pings, trace routes, but we also do a little bit. We focus mostly on this layer 3, like the IP layer. But a little bit on applications, like DNS, we do TLS, NTP, and Vesna is going to talk a little bit more about HTTP measurements. We support IPv4 and of course IPv6. And as I said, in 2020, earlier this year, we launched software probes. Yeah, there's a lot of interfaces that you can actually get data files. You can get all the data that we got in a single day. I think 14 days worth of that data. We have APIs, so you can get towards this destination. We have a command line. There's widgets. There's tools. There's code. If you're interested in this data, anyways, atlas.ripe.net/docs has this. Oh, there's also streaming data. So if you want to get the data out of Atlas as soon as as we receive it, you can just subscribe to whatever measurements you want, and you can actually get that data as fast as possible from us. So that's also really nice. Okay, we have contact information. I think I need to speed up a little bit here. So RIPE RIS, this is the second big data collection. We collect BGP routing data, and this is like the image you see here is a visualization of where we do this from. We have the red points are our we call these route collectors, but some of the route collectors actually collect data from internet backbone routers. The green dots that are not physically close to them. So we are actually have a lot of feeds of routing data. So since 1999, if you want to know more about this, ris.ripe.net, we're going to improve that webpage because it's a bit outdated. And we have a mailing list of, and for those who don't know what BGP is, this is my I find this super interesting. But it's also hard to explain. It's the thing that makes inter-domain routing work. It's the thing that makes your packets go from your home towards that web server in Bangladesh without you having to figure out how to actually do that yourself. It's the border routers. They receive the routing information from all over the internet, and we just collect all of this sort of. They chat amongst each other. Where should I send this packet? Where should I send this block of, send it to these three networks. And we just ingest all of that data. And from that, you can get a lot of interesting things about if outages happen, if people remove blocks off the internet, or if hijacks or stuff like that happen. You can see that typically in BGP data. Again, many interfaces. We have data files, so you can just download all of this data. It's quite a lot. You can also stream this. You can get yourself alerted on what's happening with the address space for a certain country or for a certain network, an autonomous system number, as we call them. And there's a very big part of this is widgets and APIs in RIPEStat. And RIPEStat is another big project. And I don't have, this is basically, if you want to know something about a single autonomous system, a single network, a single IP prefix, this is basically the place where you can go to and get all kinds of data sets in a single place. So you get RIS data, Atlas data, and all kinds of other data about a single resource in a single place. Super interesting if you're researching networks like that. So that's stat.ripe.net. And this data is also getting used in a lot of third-party tools. For instance, Data IOTA, which is going to be covered later on in this series, I think. The Internet Health Report is something that's produced at IIJ, which uses a lot of our data. Artemis is a project that detects BGP hijacks, and the BGP Alerter is another project that detects BGP hijacks. So that's we got the question queue again.
Yeah, so we did receive actually some questions from the channel here. We have Hamza who asked, how are regions decided, accessed?
How are regions? I'm not sure I understand the question, so I'm gonna. What regions we actually collect data from? I think that is. I hope I get your question right, Hamza. This is all voluntary. So if people want to contribute data to us. And in RISC, for instance, this is like somebody who controls a network border router that speaks BGP, that speaks this protocol, can contact us, and we can just set up a session so we can actually get the data. So it's called a peering session, and we try to collect them from as diverse regions as possible. So if there's regions that are not covered at this point, we would like to see how we could actually do that, if that's feasible. So yep. I hope that answers it.
Yeah, he actually followed up saying that I was asking about the graphic where you had countries, and then followed up by confirming that the answer that you provided is in fact what he was looking for. So thanks for that. Another question comes from IMV. And the question is about IPv6. IPv6 is spreading very slowly around the world. What are the problems with this? Because the IPv4 prefixes are already over? Question mark. And they follow up to say, in fact, now there is even a slight rollback in the implementation of IPv6 among resources on the internet.
Well, I don't know about a rollback. Because what I've seen in all the images is that it's increasing, but it's increasing slowly. That's true. But if you look, for instance, for very big content like Google, they see a lot of IPv6. So it also depends on where are you looking, and it's very unevenly distributed. There is people talking about IPv6 only already. But I get it that if you say it's slowly deploying, yeah, that's we would have loved to see it more.
Yeah, so we try to encourage the deployment of IPv6, and last week Monday, on the 8th of June, we had a whole day event with people talking about their experiences and their deployments, and all the videos are available from our website. So if you're interested, you can check it out there, but we would like to move on to the current topic, and you can reach us on email addresses that are published here, so we can pick this up later.
Yeah.
Okay, great.
So
that's all the questions we had.
Thank you.
Okay.
So now I'm going to take over and talk about one of the possible ways how you can practically use RIPE Atlas, and that is to measure the reachability towards your website. Now, that is not part of the regular features of RIPE Atlas. And that was a very conscious decision. At the beginning, we did not want to measure the application layer because we were interested about the internet infrastructure, and our main target audience were the operators, the ISPs, and so they were happy with the pings and trace routes and all the rest. However, this project is already 10 years old, and so the users have been asking for HTTP measurements. Then we had a discussion with the community and still decided that we're not going to allow HTTP measurements towards arbitrary websites. And so technically we have deployed HTTP measurements, and they are running as built-in measurements towards all of our so-called anchors. So there's about 400 servers that targets for these HTTP measurements. And the only thing you can do also as a user is to check how fast a small file and a large file can be downloaded. So that's it. Now, why don't we want to allow these? Well, we would put the hosts of those probes, of those measuring devices, in danger if somebody would use their probe to access the websites that are illegal in their country. So we could not get the consent or informed consent from all these people to actually allow this to happen. And so we don't want to put them in danger. We don't want to put their cats in danger either. So if you still want to do something like reachability measurement, so I will skip this. One of my colleagues has found a workaround, and that's the so-called TCP ping, which is actually a trace route with the very specific parameters, and that mimics the behavior of the TCP handshake, and so the delay to reach that network is the same. So he has proven that. He did a lot of experiments and published the results. And this is also a good opportunity to tell you how the actual measurements can be done. So you can either do them through the web interface or through the command line interface. The web interface is self-explanatory. There are a lot of options. You can click and point and choose. And for both of those, you will need to actually spend some so-called credits. Why do we have that? Well, it's in order to kind of achieve the fairness and to avoid the overload of the system. So we actually limit all the users by the daily spending limit of the credits. And we also reward the people who host the probes by generating these credits and like giving them to the hosts. And so that people who host more, they can spend more. Now, if you're not already a user of RIPE Atlas, there are other ways that you can get those credits. Somebody can give them to you. They can be transferred from one user to the other. And today, if you are watching this, and also if you are watching it on video, if you use this voucher, I will try to center it, the voucher is called Glitter. And Emile has glitter on his nails, and I also have it, which is a tribute to Internet Freedom Festival, who is using glitter as one of their keywords, and we love it. So we just made up this voucher. So you can get 1 million credits if you reclaim this voucher within the next year. Well, the first 100 people. Otherwise, if you need many more credits for your research, again, reach out to me or Emile, and then we will just give them to you in return for you publishing that you have used RIPE Atlas for your research. And there is also command line interface. It's available on GitHub, and it's actually included in many Linux and other distributions. You can download it, you can contribute to it. Just like with any other measurements, we show you certain visualizations, like the color-coded map to show where the source probes are, and you get a list of all the probes and their latencies, and you can download the data itself as a JSON file. Here's the link, and that's everything. Before we move to the next section, which is Emile again with his guitar, unless...
Yeah, should I do the question?
Okay, we don't see Arturo jumping in, so we just move on.
Yes. Yeah. Hello. Internet health. So one of the things we do with the data is, and what people ask us for is like, how are particular parts of the internet doing? What can you see in your data? And I guess that's the same for other internet measurement projects. So this is a very recent one. We looked at how COVID-19, I guess everybody here is familiar with what COVID-19 is doing with routing, it's a lot of data. So what we actually wanted to see is that the ASs, so the networks, if they stop changing their configurations much. So there was a little bit of a fear that people could not get into data centers, and so and the people who operate the network, they might actually be decreasing or maybe increasing the maintenance of the network. And what you can actually see here is the signal that we found in our data, which is like, if you look at this graph, you see that the gray bars there, that's the weekends. So you can actually see in the weekend there is less changing of the network than weekdays. So that's actually pretty cool that we have that signal in there. That builds confidence that this really is the signal that we're looking for. But during the COVID time, we just saw that flat line. So you don't really see a trend in here, no more, no less. So people are just able to do their maintenance of networks. It looks like stable BGP activity. At least that aspect of it is stable. People are taking responsibility and maintaining the network. We have a link in there if people want to read more about this. We are collaborating with, and we had an online hackathon that Vesna organized. And one of the collaborators there, Roman van Touge, did a really nice thing in that he processed RIPE Atlas delays and actually looked at a time before Corona when a lockdown got in place, and then what the current situation is. And this contains, this slide contains links to that, to a RIPE Labs article about that, plus to the directly to the page. And yeah, what you see here again is, as we know, the internet is keeping up. But we see delays in some locations. And this, for instance, is Telecom Italia, where before the lockdown you didn't see, you saw basically stable delays, and then during and after you see it going up and down, which are signs for a little bit of congestion potentially. So that's really nice. And another study where we look at the internet health, but at a completely different time scale, is this study. And I really like this. This is a collaboration between Seni at Citizen Lab and Roman at IIJ. And this combines sociological fieldwork and internet measurement in Crimea specifically. So there was political events going on between Ukraine and Russia. I have to be very neutral in this. So the political control there went from Ukrainian control to Russian control. And what the study actually shows is that the control over the internet shifted later than the political control. That's basically so the sociological fieldwork is interviews about that, and the internet measurement part of that is looking for the signal in the data. And you can actually see here in this slide that there was a lot of change in Crimea, whereas the Ukraine and Russia, they had stable upstream networks. Really interesting stuff, I think. There's another thing we do which is called country reports. That's what the RIPE NCC does. What we do by ourselves. We have an excellent external relationships team that really dig into our data and try to really answer local questions about this. We have what's called the SEE region, so that's Southeast Europe. They did a report on the full region, what we can see in our data, did a report on Germany, and a report on the Dutch routing system. And there's upcoming reports about other parts of our service region. So if you're interested in this or have suggestions about this, we're very interested in that. Outage, it's still me. It's okay. So we don't do an interlude.
I don't know if you wanted to take some questions. We had just a few small ones. One, Hamza was asking, where do we find links for these things, referring to the Internet Health Report and the previous slides about the reports pertaining to COVID-19?
RIPE Labs, COVID-19.
Yes, they are on RIPE Labs, labs.ripe.net/COVID-19.
Yeah.
But they should also be, the links in the slide deck should work. And if not,
we can also add some links in the video description when we upload it. So you know, we can add links to that.
So yeah, if one of the links is not working or you cannot find it, then please get back to us. Or if you want to know more about these studies, then we'd be happy to elaborate.
And the other question was, what is meant by internet control? like where it routes through?
Well, it's control plane. So that basically see this as all the networks on the internet try to tell each other where they should route the traffic. So if we are two neighbor networks on the internet, I tell you what networks I can reach and you tell me what networks you can reach, and we exchange this information, and then both you and me can make better informed decisions about where we should route the actual packets. So that's the protocol that controls it. So it's like control plane, and it's not in a
as opposed to data plane.
Yes, it's more as opposed to data plane. So this is the layer that actually makes the routing work, and the data plane is actually packets just flying there, and the routers just know where the packets should go because they learned that from other routers in this control plane. I hope that's maybe a slightly different attack on it that explains it better.
Great. Yeah, that's all the questions we have for the moment.
Okay. Yes. So this is the outages part. We've been what our data also shows is wherever outages happen. So we have two what I thought really interesting case studies. The AMSIX, the Amsterdam Internet Exchange, had an outage it's 5 years ago, where we could actually, because we had so many RIPE Atlas probes there, we could actually see is like the story always is the internet routes around damage, and that's how it was designed, but does it really? And so we had two use cases, and in this case you can actually see the green is okay. The internet just did what it used to do. The blue is internet routing around damage. So a particular part of the infrastructure was damaged, and then the internet just routes around it. But you can also see there was a little bit of a part of the internet that for a very brief moment actually was damaged here. And we can actually look into that with our data, which I think is pretty cool. And this actually is something that Vesna looked into. What you can actually see here is that in Croatia had an earthquake in March. So they had Corona plus earthquake. And so you can actually see, and the left image here is part of RIPE-Stat, that where you can see the routing statistics for Croatia. You can see the number of networks there dropped a little bit. So there was actually a visible signal in our data, and RIPE-Stat uses the risk data in this case. So that's the routing data. And if you look to the right, there's this Internet Health report that uses a lot of the RIPE Atlas data that actually looks at RIPE Atlas probes disconnecting. And if lots of probes disconnect at the same time, it gives you a signal. Another example is earthquake in Nepal. And again, to the left, there's the RIPE-Stat, which uses the risk data, where you can actually see all kinds of variations happening due to network outage. To the right is a visualization that shows RIPE Atlas. So you sometimes don't see any data there, which is a signal you typically see during these events. Other stuff we had, like around countries, it's always interesting. We had a really interesting collaboration with Colin Anderson, the internet in North Korea. To the right, there's a picture that combines active measurements. So we measured their DNS and also the BGP. So the red line just shows there should be no data, but still we were able to send data in and out. So that's really interesting. Iran and K-root, there's a link there again. And to the left, there's a view of internet meddling in Turkey. And this was 2014, when all of a sudden Google's 888 became super low latency from Turkey while they did not have presence there. So we can actually see if people are mucking with the internet in particular countries, and in this case it was impossible delays. So power outages, like around Amsterdam, we are very well deployed, so you can actually see there was a big outage, so you can just see stuff disappear, like RIPE Atlas probes going down. Same signal as we saw for the Croatia earthquake. Well, there's all kinds of Time Warner Cable, Facebook outage. Sometimes we look into this and you really see interesting things in our data. So if you're interested in outages, we have a wealth of data to explore. Natural disasters, we had the Hurricane Sandy, where we saw stuff shifting from one subsea cable to another. For Typhoon Haiyan, which hit Philippines, and we again see RIPE Atlas probes go down that are very close to the hurricane path. Cyclone Pam and the internet in Vanuatu, so small islands. We can also see things there because the RIPE Atlas probes are deployed on even on small islands like Vanuatu. So that brings me to the end of that part and a queue for questions.
So, no questions. We move on to other type of measurements, which is DNS. We thought this would be interesting for the audience of the people who are more interested in censorship, because RIPE NCC cannot analyze that too much, but we did cover some of it. So DNS is a big part of how does the internet operate, and we ourselves operate one of the root name servers, so we also measure towards root name servers and show the data in some of our internet maps. This is 10,000 probes over the last 10 years towards hundreds of Anycast instances of root name servers, and all the data is available for you to download, analyze, and view. So going a little bit less global is the service called DNSMon, which is from 400 RIPE Atlas anchors to about 40 country code top-level domain servers. And again, that is available to everyone to see that information, but it's mostly interesting for the operators themselves to show what is their uptime and are there any outages and so on. If you like that kind of visualization, you can schedule your own measurements, and you would have to pay those video credits. This is a service called DomainMon, and it's available for the second level domains, and it's not going from anchors but from probes, and still you can actually schedule from hundreds of probes all around the globe towards your domain that you're operating or that you find important. And you can find a lot of details there. You can also schedule regular DNS measurements, and you will see these visualizations as we have already showed them before. And we also prefer you to not have to start your own measurements, because most of the people actually just query a very popular domain because they are interested in that one. And so we have scheduled our own system measurements towards popular domains and towards some random domains that we have randomly chosen, and that data is available for everyone to download and analyze without setting up extra measurements. We're trying to be a bit sustainable, but that goal is clashing with the wish to have more and more data. So here are the examples of the analysis that has been done by our users about the DNS censorship or blacklisting or hijacking or DDoS attacks. They're all available on RIPE Labs. So that's labs.ripe.net. probably /DNS. We are very fond of the shorteners. And we also had a hackathon. Oh, Emile is having the same T-shirt as me. So this is our T-shirt fashion show. So during that hackathon, 2 teams actually did the similar thing, trying to figure out how to find the hijacked resolvers. And they found out that quite a percentage of probes were actually suspiciously behaving or being weird. And they also identified that some countries have many more instances of that than the average. Next topic, introduced by guitar. We see Arturo, but not hear him.
There we go. I unmute my microphone. So we have a new question from the internet. Leonid asks, is there any decision on custom URLs and headers for HTTP measurements towards anchor IP addresses? Is it also considered potentially risky activity for the probe hosts?
Yes, so it is not considered a risky activity because there is no content on those anchors. So it's just a mini web server that serves 2 files, a large file with some kind of random payload and a small file, and that's it. So that was compromised to allow people to perform HTTP measurements, but not towards a target that they choose. And if you really want to use RIPE Atlas to let's say monitor your web servers, then placing an anchor next to your web server would be a good trade-off again, because you will be measuring reachability towards your infrastructure, but not specifically of that server itself, but of the anchor which is next to your web server.
Yeah, I mean, I think the question, if he allows me to interpret it, maybe is that I think he was asking if it would be considered by RIPE to add support in addition to just doing a fixed HTTP request that fetches this content from the anchors, also adding an additional level of configuration for a user that wants to trigger a probe to say, okay, contact the anchor, but instead of using the default set of HTTP headers, use this custom header, which is chosen by the whoever instruments the measurement.
So I'm not sure how much of that is already deployed and implemented. There are some parameters that are possible to change. And if Leonid, I think, would like us to consider that more specifically, please get in touch with us or post it to the mailing list so that we can discuss it with developers and see if we would want to do that feature or not. So it's a bit difficult to talk about it or to decide it right now. But thank you.
Fair enough. I would also find that feature very very interesting, and would give my thumbs up to that.
Okay, so we can talk about this later. Thank you.
Okay. Yes. IXP country Jedi. So 3 terms of things that I like. This is a little project that I did myself on top of RIPE Atlas. And we get a lot of questions about, like, does internet traffic stay in a country? And if you talk with various people about this, you get various answers. And can we actually measure this was basically the question. And this is an attempt to do so. So what we actually do is we take selected probes in a country, in a given country. Say we do this for Belgium. So we take all the probes in networks in Belgium and then basically do a measurement between what's the path from A to B and from B to A. And so you have a lot of path, and you basically ask yourself the following questions. Are they going out of country? and you actually need to have decent geolocation. And for this type of data, what you typically do in MaxMind won't work. So we try to do that other ways. And do we see exchange points in the path? So internet exchange points is very big or very important places where people can connect to a lot of other networks at the same time. We actually have two variations of this, which is the probe-to-probe version, which is like you just take the probes and you do the mesh. And we have what's user-to-user. So if you have user-to-user connectivity, how important is that still? And with WebRTC and like people directly interconnecting to each other, it seems to become a little bit more important. But what we do there is we figure out which probes are in networks that have a lot of users. And so we weight them based on the number of users that are in there. And I'll show you some examples of that. We also call it the eyeball Jedi. So what you actually see, here's a couple of examples of measurements that we have. And did I put the, oh yeah, the probe-to-probe has the URL to a web page that has more information about this. So here you take Hungary is to the right, and you can actually see paths going out of Hungary if you look carefully. In Finland, the paths stay nicely in Finland, and for Bosnia, it goes to Hungary, to Vienna, to Sofia. So we see paths going out of the country quite frequently for as far as we can measure them, which is pretty interesting. We also make like a matrix type of visualization where we the green colors are they stay in country. And so for a couple of countries, you can actually see for some, everything stays in country, and for some, we actually see paths going out of country, and you can actually cross-correlate to are IXPs involved or not. So the IXPs are the darker colors in this case. And here another set of countries, and we can also, so if you take the same set of countries and you just look at which networks are between the users as far as we can measure, you can actually see some really simple connectivity graphs. Like for instance, what we measure for Montenegro is the users are in very large networks because each segment is a single network, and they have very simple interconnectivity, in this case via an exchange point. Or you see complex setups. For instance, the Bulgaria and Serbia one are way more complex here. I find this type of stuff fascinating. I hope you find it fascinating too. So that brings us to the end of our presentation, I think, at least to the final thoughts.
Yeah, so yes. We would like to hear more from you. We have 10 minutes. And we want you to get involved. There are some instructions on how can you do that. And we also want to warn you that knowing all this, now you have great power, and you have also earned a great responsibility to use this information carefully and ethically, and to consider who benefits from all these measurements and the data that we are collecting. And can we hurt someone by analyzing all this, and how can we avoid doing that, and how can we use all the data and all the measurements for the greater good? So this would be our invitation to you.
Be awesome. So
great. Thank you for that very interesting presentation, Vesna and Emile. I mean, we've already addressed several questions throughout the presentation. I guess we'll encourage people to leave more questions if they have them in you know, on the YouTube channel, on the OONI Slack channel, on the pad that we have here that you can see in the image. So yeah, I mean, I guess one thing, I have one question, which I think interests me from like with respect to the work that we do at OONI. I guess what is sort of the process that you folks go through in evaluating the ethics and the risks associated with certain experiments that you decide to implement and roll out on the platform? Like, for example, I recall in the past, you didn't have, for example, the HTTP request test. And then at some point you somehow understood that doing it, but with this caveat, was like somehow acceptable. Like what sort of process do you go through to evaluate those sorts of risks?
I can answer that. It's a very organic process. It's not completely structured or kind of determined. So we talk internally about what would it mean, what would it take, and then we have a lot of long discussions with the community, and it takes really several years until we come to the conclusion, because we want to consider all the pros and cons that our community is tend to bring up. So there are needs by users, then there are concerns about other people and other users and the networks and the reputation of the RIPE NCC and the RIPE community. And this was all happening several years ago, when we didn't actually consider too much the legal liability of the RIPE NCC. But nowadays, we would also have to consider that. So for the first 5 years, we didn't even have the terms and conditions for the users. And so it was very difficult to determine, is it what we want to add or use this platform for actually according to the things that the users have signed up for? And only after we even introduced these HTTP or not, we have came up with the terms and conditions that the users then have consciously accepted. So for the rest, it was just the concerned people in the community in the mailing list, thinking together and making a decision. And we call this process, which happens in the RIPE community about many other things, not just RIPE Atlas, policy development process. So there are stages and there are ways to involve people and kind of extend the process, but also to condense the feedback and come up with a decision that then we implement. And then if people are unhappy with that, we start the process all over again. So the situation with, for example, HTTP measurements is as it is now, but it can change. So we encourage the new audiences to take part, because the needs of the users change, and we can actually change the technical decisions according to that.
Yeah.
Thank you. That's very, very good explanation. Thank you. We have some other questions coming from the chat. IVM asks, do you monitor BGP health? And then clarifies what they mean by BGP health, and they say, how acute is the BGP hijacking problem?
How acute is depends if you're being hijacked or not. But yes, so there is a problem. We know that, and it's like it's unclear. We cannot see from our data if hijacks or if changes are intentional or not. Sometimes you see changes in BGP, and like we provide the tooling to actually for people to, or we provide the data for people to see these changes, but we cannot see if it's intentional or not. Another thing that I should mention while we're on this topic is the RPKI system, the RPKI infrastructure. So there is a very big effort going on in the network community to secure the origination of address space in BGP right now. So people, there's like certificates, like public key infrastructure. So it's similar to what HTTPS is in your browser for internet route origination, and we are the RARs play an integral role in that. We keep these repositories up to date. We measure this. So we provide building blocks for the internet, or we help facilitate. That's I think what is the role that we're playing there. And yes, there is a problem.
I wanted to add something.
Yes.
So it's possible to actually monitor your own prefixes and to see if your prefix has been hijacked. It requires quite some work, and there are tools for that. And one of the recent new ones is something called BGP Alerter. And again, you can find that on RIPE Labs. So that's Massimo who created it.
It's in the slides.
Okay.
It uses risk data. We have a streaming interface, so that's when we just give you the fire hose of all the data that we get, and you do useful stuff with it. BGP Alerter is one of the things that does useful stuff with that. And
on GitHub, there is many more tools that have been developed during the hackathons. And well, they are the prototypes. So however much people could actually create during 2 days, and you can take them and repurpose them for your own usage.
Yeah.
Great, thanks. And IBM thanks you for the answer. I think that is all we have in terms of questions. Are there any last things you would like to say before?
Maybe incentivize people to not ask questions, because Vesna can also juggle for the last couple of minutes. Okay.
There you go. Okay, that's it. Thank you, everyone, and see you online. Thanks, Arturo, for all your questions and for your patience with setting up everything with us.
Thank you, Vesna and Emile, so much for joining us in this Internet Measurement Village experiment, and for showing us the great work that you folks are doing at RIPE.
Thanks.
Okay, thank you.
See you. Bye-bye.
Ciao, ciao.
And thank you to everybody who tuned in from the internet. And yeah, we'll see you again tomorrow on this same channel for another presentation, which will be at 2 p.m. UTC, and it will be by Felicia Antonio on the Keep It On campaign, advocating against internet shutdowns. So that's it. Have a great day.
Ooh.